Hello everyone, my name is Mahamadun Nobi and again welcome to my YouTube channel. Today I will talk about gradient calculation in Pytorch. Sometime we write machine learning and deep learning models using Pytorch, and in Pytorch while writing the model we need to write a training loop. In the training loop we calculate the gradients of the loss function and update our model parameters. And these things are done within 2 or 3 lines, like optimizer.step and loss.backward, and all the things happens in the background. So today we will know how these gradients are calculated and all the things. Okay, let's start. First of all, we will import torch. Then we will initiate a variable torch.tensor 1 2 3 4. We will give a data type is equal to torch.float 32, and then if we print x, it will look like this. 1 2 3 4 is it's a tensor. Then we will do some calculation using this variable, like if we do y is equal to x square plus 5 into x plus 6, and y is equal to y dot mean. Then if we print y, then y will be a scalar. Okay, now we want to calculate the gradient of y with respect to x. I did some averaging here, y dot mean. The reason behind that is if we want to calculate the gradient using Pytorch, the final product of the function should be a scalar. We also can calculate gradient of a vector, but that will be bit complex. We need to calculate using through Jacobian matrix, and we need to pass some other vectors to the function. Okay, let it go. We'll do some simple calculation tonight with scalar. If we have only done this type of calculation, then the output will be a vector, but that will be complex, and these things makes the output scalar. So let's go to the whiteboard and see what we want to do. Actually, we have a scalar like this: 1 2 3 4. Then we have y is equal to x square plus 5x plus 6. Then y is equal to y divided by 4, because there are 4 numbers, then it will look like 1 by 4 x square plus 5x plus 6. What we want to do, we want to calculate the partial derivative of y with respect to x, or gradient of y with respect to x. Then we will do like dy by dx. Then 1 by 4 is constant here, then x square will be 2x, and 5x will be 5, and 6 will be 0. Okay, let's see how this thing look like. Dy by dx will be a vector. If we put 1 here, 2 into 1 2 plus 5 7 divided by 4, 7 by 4. Then 2, put 2 here, 2 into 2 4 plus 5 9, 9 by 4. Similarly 11 by 4 and 13 by 4. We can write them in decimal points, like 7 by 4 is equal to 1.75, 9 by 4 is equal to 2.25, and 11 by 4 is equal to 2.75, and 13 by 4 is equal to 3.25. We want to calculate these gradients using Pytorch. Okay, let's do it. First of all, we need to tell the Pytorch function that we want the gradient with respect to these variables, like x. We want the gradient of any function that will be calculated later. We want the gradient of that function with respect to x. Like we will tell requires grad is equal to true. Okay, if we print again, then we'll see like x now requires grad. by doing this we can ensure that we will be able to calculate the gradient of any function that will be calculated using s in future with respect to x. Okay, let's go ahead. Then we again calculate this function with respect to x. Y is equal to x square plus 5x plus 6. Now this it's time to calculate the gradients. To calculate the gradients we just need to write y dot backward. It will do dy by dx. It will calculate the gradients of y with respect to x. Now if we want to print the gradients, then we will print like this: print x dot grad. Yes, 1.75, 2.25, 2.75, 3.25. They are exactly similar with our calculated values. Okay, that's how we calculate gradient with in Pytorch. But there is another thing. If we run these cells again, it will give different values, like 3.5. It doubles the values. It adds the gradients with the previous gradient. It didn't delete the previous gradients. That's a problem. So we need to do one thing, that when we calculate a gradient and our work is done, we need to delete the gradients from the variable, like x dot grad dot 0. Then the gradients will be deleted. Now if we run the cells again, it will give the same results again and again. It will give the same results again and again. Okay, see the difference again. If we delete this line and run these things again and again, it will add up the gradients with the previous gradients. Now it's 1.17, 1.75. This time it will be 3.50. Yes, if we run again, it will calculate the gradient again and add up with the previous values. So after the calculation, we need to delete the previous gradients, like x dot grad dot 0. Okay, that's how the gradient is calculated in Pytorch. Okay, now there is one more thing to know. Here we initiated x with requires grad. That means it will requires grad in the future every time we use this variable. But after, when the model is trained and we are doing some evaluation using it, we don't need the gradients there. So we need to stop. We need to detach the variables from gradient. We can do this like x dot detach. Now this is a normal tensor. Previously it was a tensor with requires grad. It required grad. Then when we detached it, it doesn't require any grad now. That's all for today. Thank you very much. Thank you for